Let's talk Boyles Law. This is the first gas law of 9.2. There's a total of 3 gas laws: Boyles Law, Charles' Law, and Gay-Lussac's. So we're going to work with all 3 of those, but we got to start with Boyles. So up on the board, we've got a problem. Go ahead and take some time and try this out right now. So pause the video when you're ready to continue. Play it. We'll go over it together. Sound good? Okay, so Boyles Law, PV equals PV. There's only really one rule when it comes to Boyles Law, and that's that your P's and your V's need to have the same units. So whatever pressure you start with, you gotta have the same units at the end. Whichever volume you start with, you gotta have the same units at the end there too. Now, if you read the problem, that is an issue because our pressure units, one of them's in torr and the other one is in bar. So first thing we're going to have to do is we're just going to have to figure out, like, kind of plug stuff into the equation. Where does everything go? So let's do that first, then we'll take care of the pressures. Sound good? Great. So I'm starting with 456 torr because that is my starting pressure. Now the problem says that it was a container of unknown size. So V1 is actually something we don't know. We're actually solving for V1, which is a little bit strange because in most problems, usually we ask for a 2, a V2 or a P2. Just be aware, we can ask for a V1 or a P1. On the other side here, we're dealing with a new pressure of 2.4 bar and a volume of 1.54 liters. Now, you don't have to include your units here. I think it's helpful because if you do that right away, you'll see this issue with torr and bar. So we got to convert them. You could convert torr to bar, or you can convert bar to torr. In this case, I chose to do torr to bar. It's because I felt like it. I don't know, it's just how I be. So here we go. When you convert torr to bar, very similar to what we did in 9.1. Here's the torr. Torr goes on the bottom, bar goes on the top, and we get a final answer here. Now, once again, you're going to want to look at your periodic table to figure out what exactly the numbers are. I'll tell you that torr is 760 and bar is 1.013. Make sure that you have bar somewhere in your periodic table. That is a number that's not printed on your printout, so you're definitely going to want to add that in. Sound good? Now, we take 456 divided by 760, multiplied by 1.013, and when we do that, we get a new number that is no longer 456 torr. It is now 0.6078 bar. That's what my calculator spit out. It was only 4 numbers to write down. I guess 5 if you count the 0 in front there. So I just wrote down all of them. In this case, since our final answer is going to have 2 sig figs, I guess you really technically only need to write the first 3 down. I usually like to write down 1 extra sig fig from a calculated number, just so that way I don't have any rounding issues, my numbers aren't off. If you do round them to 2, sometimes your numbers can be slightly off, so just be aware of that, something to look out for. Let's solve this problem here. In order to solve this problem, V1 has to be by itself. So to isolate V1, I'm going to divide by whatever numbers are on V1's side, just to kind of get rid of them. So I'm dividing by 6078. That's going to cross those out. And then what I'm plugging into my calculator is 0.6078, and then the 2.4 times 1.54 divided by 0.6078. When you do that, you get a number. Hopefully you got it already. If not, just pause the video one last time and try it out. Okay, so if you did the thing, you would have gotten an answer. I think it spits out as something, I don't know, rounded, it's 6.1 liters, and obviously there's numbers after that, but it rounds to 6.1. That's Boyles Law. So Boyles Law goes along with Charles and Gay-Lussac's. Those 3 laws make up 9.2. So at the end of 9.2, after you've watched the Charles Law and the Gay-Lussac Law video, there's a short little review, and that review is 3 questions. Should be fairly straightforward. Go ahead and try that out, and that's a great way to kind of test your ability on your own to do these problems. As always, let me know if you have any questions. Thanks for watching, and have a great rest of your day.